In this lesson, we are going to learn about linear regression and how linear regression actually works. So let's say you are a movie producer and you provide money to produce movies, and when the movie makes money, you make money, and when the movie loses money, you lose money as well. And you have used all of your life savings, you have sold your car, you have rented your house, you have even gone as far as to take a loan from the bank and used all of that money for a horror movie. And after providing all of that money, you get the information that the name of the movie is going to be Zombie Vampire Sharknado Part 1. Now, if that's not a bad name for a movie, then I don't know what is. And you want to know if you're going to get bankrupt because of this movie, or this movie is actually going to make money and make you rich. Because after all, there are many movies that have had an extremely high budget, but they have made fortunes. So you want to know what actually makes a good movie. Maybe it is the actors that's in the movie. A movie featuring a more famous actor is probably going to make more money. Or it could be the scripts of the movie. Or it could be just the overall budget of the movie, because you need to have a high budget to pay actors and create good scripts. And marketing also costs a lot of money. So you come to the conclusion that the budget is the best thing to look at, which seems promising for you. And you want to find out if there's a way that we can know how much revenue big movies made and their budgets, and find out how much revenue our movie will make. For example, movies like Avatar, The Avengers, or Titanic made a lot of money, but they also had an extremely high budget. And using that data, you want to figure out if you can check how much revenue or profit your movie is going to make. So for this, you would have to use linear regression. Now let's look at what linear regression actually is and how it works. So for that, we are going to use some sample data. Now we won't be using a complex data like this one, but we will be using a much more simpler data to learn about linear regression. For example, this data. Now in here, we have the movie budget and the revenue. And before moving on, I want to tell you a couple of things. So the first thing is that the budget is called the feature or the independent variable because it is not dependent on anything else. And the revenue is called the target. It's called the target because our target is to predict the movie revenue, and it is also called as the dependent variable because the revenue depends on the budget, and the axes that you see are called data points. Now let's move on. So the job of linear regression is to represent the relationship between the target and the feature in a straight line, like this. Now how does linear regression actually come up with this line? How can it find the best fitting line which will best represent the relationship between the feature and the target? So first, let's look at what a line actually is. We know that we can plot y as a function of x, and that's a line. And if we cut the line at the point 10, then the line will have a y-intercept of 10. And if for every 2 increase in x, our y increases by 1, then we know that the slope of the line will be 1/2. And we can plot the values inside the function of the line, which is y is equals to mx plus c, where m is going to be the slope and c is going to be the constant or the y-intercept. And this will be what we'll get. Now I have a question for you. Which part of the equation do you think tells us how strong the relationship between y and x actually is? The answer is the slope. The slope is the key to know how strong the relationship between y and x is. So let's look at a couple of other lines. Let's look at a line where there's no relationship between x and y. That would be just a straight line, and our equation would look something like this with a slope of 0. Now we could have another line which is very steep like this. Now this line would have a very high slope like 2. But normal mathematics is very far from machine learning, and in linear regression we don't actually know these values. That's why we call them parameters. And we use a different notation as well. So instead of c for the constant, we actually use theta 0 like so. And instead of m for the slope, we use theta 1. And the order is also changed. So first we have theta 0, then plus theta 1 x. And the final thing is that instead of y, what you will see in most cases is h theta of x, where h stands for hypothesis. So this is going to be the equation of a line. So this is our new equation. Now this might look extremely complicated and intimidating, but all you're looking at is just the equation for a simple line. Now the reason I'm telling you this is if you maybe pick up a book on machine learning or you're reading some articles, then you are very likely to come across this equation because it is very popular in machine learning. Now here comes the big question. How do we actually determine which line is the best fitting line? If you just look at the data, then we can draw multiple lines. For example, this green line or this purple line. We can also draw this red line. So how can we determine which line is the best fitting line? If our data looked something like this, then our job would be very easy. We could draw a line like this and it would be extremely accurate. But real world data looks something like this. So it is extremely shuffled. And each time when we draw a line, there will always be a gap between the line and the data points. Like so. So as you can see, there is a gap between the actual point and the value on the line. Now this point on the line actually has a name, which is the fitted value or the predicted value. Now the thing that we need to focus is these gaps, because these gaps are going to tell us what is the best fitting line for our data. These gaps also have a name. These are called the residuals. Now how can the residuals tell us which line is the best fitting line? Well, let's say we draw another line right over here. Now if you look at the gaps between this line and the data points, then the gaps are a lot bigger, meaning our line is going to be that much worse. So these residuals can actually tell us how good our line is. Now let's look at that first residual. So the value of that first residual will be the actual value and the point on the line. And the same goes for the second data point and for the third data point, so on and so forth. Now let's say that we have actually calculated the values for each of these gaps and we get the values of 10, -3 and -4. Now what we can do is to just add these up because we actually have negative numbers. So to fix that, what we do is instead of just adding them up, we square each of those values like so. And by squaring them, the numbers will no longer be negative. Now this value that we get is a very important value. The goal of our linear regression is to minimize this value as much as it can, and that will determine our best fitting line. So it has to choose the best theta 0 and theta 1 value to minimize this number. And this number actually has a name, which is the residual sum of squares. Now that was about linear regression and how it works. If you found this video helpful, then don't forget to give us a like and subscribe to our YouTube channel to get notified when our next video comes out. I'll see you in the next lesson.